All right, algebra, let's talk about lesson 36. We're going to do, starting with the distributive property of rational expressions. That contain positive exponents. A lot of we're ready on that. We'll talk about negatives in a little bit, but let's start with one thing first. This is in your algebra books. This is found on page 146. And what we're going to do is we're going to learn how we will distribute it. For example, what we've been doing in the past is when we multiply two fractions, we multiply the numerators to get a new numerator and denominators to get a new denominator. For instance, 2/3 times 5/7 equals 10 over 21. We get a new numerator, new denominator. Since variables stand for something that's not specified, unspecified real numbers, all the rules for real numbers apply to these variables. And since that's the case, fractions that contain variables are multiplied by using the same rule. So mx over 4y times ax times 2y equals amx squared over 8y squared. The distributive property of real numbers is also applicable to expressions that contain fractions. Expressions that contain fractions are called rational expressions. So that term you should write down. Rational expressions is the term that we use when we are talking about expressions that also contain fractions. So a good example of one of those would be x over y, that's definitely a fraction, with variables, a over y minus b equals, well, when we divide it out, we end up with a bunch of stuff. Now keep in mind that this is really b over 1. So that should serve you some good stead. Multiply the numerators. X times a is xa. X times b is xb. Notice I'm going to put my minus sign there because that's what's going there. Y times y is y squared. And y times 1 is just y, and that's where I get the y from. So we can use the distributive property, which is what we just did, to do work with rational expressions. For example, we can do m over z times axp over mk minus 2m4 p to the fourth, keeping in mind that this is really over 1. All right, so if I multiply everything together to get that stuff, we're going to use 2 steps to get the solution to this problem. So, but let's take a look at a few things that go on here. So if I'm going to multiply my m to all that and to all that, I get, and then my z to here, my z to here, I end up getting maxp, maxp over zmk minus, gets a little bit complicated, okay? So 2m to the 5th, p to the 4th over z. Okay, I do all that stuff, but before I can call this done, I should notice that I have an m here and an m here. And if I divide those away, they become 1. Since I'm not going to write the ones, my real answer is going to be axp over zk minus 2m to the 5th, p to the 4th over z. And just keep that in mind when you're doing these kinds of problems. Let's do one more to hopefully make sure you guys are settled in on this. I'm going to write 2bx with a denominator of 1 because it's all by itself, minus 4c squared. Okay? So, and again, I'm going to multiply everything to each place. I'll settle it out later. So here, here, and here, and here, here. and here. So when I do that, my first term is going to be x a squared b squared, and you can rearrange this, c to the third plus 2 a b squared x over c squared minus 4ab over c to the fourth. I will look to see if I have anything that I need to get rid of, and I don't. Therefore, I am done with my problems. Good. Now we need to look at minus signs and negative exponents. And this is found on the very next page of lesson 36. This is page 147. So we have a bunch of expressions. A minus sign in front of expression indicates the opposite of the expression, right? Minus sign in front of expression indicates the opposite. A negative exponent, though, has a meaning that's entirely different. So 4 squared equals 16, right? Something that you've done in the past. 4 negative 2 squared equals 1 over 4 squared, if you remember, when we simplify them, that we're going to do with the reciprocal, we get 1 over 16. What gets us in the problem is, what do we do with a problem that looks like that? Well, 4 squared is 16, but the 4 was negative, not 2 4s. The 4 is being squared, but not the negative is being squared. So my answer for that one, this is a review, is negative 16. But when I put parentheses around it, now I'm squaring negative 4 twice, and that answer gives me positive 16, because negative 4 times negative 4 equals 16. That's my reasoning why that's the case. So equals positive 16, so that's why it's the case. Now, what that means for us is we're going to get into some heavier territory with this. My heavier territory with this would go like this one. 4 to the negative 2 power equals 1 over 4 squared equals 1 over 16, right? But what if I had negative 4 to negative 2 power? I'm going to work this problem the exact same way to get 1 over 16. Then I'm going to remember that this was negative, so I'm going to write negative in there, and that becomes my actual answer. So keep that in mind as well. Now, what about those pesky parentheses? That the minus sign is being protected by these parentheses. So in this case, I write my answer like that, and then I am going to actually solve what I'm doing. The parentheses are protecting the negative. That gives me 2 negatives when I square the 4. I get 1 over 16 as my answer. All right, so what I'd like you to do is try practice B, C, E, F for tomorrow. Thank you.